Hello student, and welcome to our new lecture, which is for week number 12 and week 13. Inshallah, in this in this slide, inshallah, we are going to discuss structure of automatic control system and the control circuit method of operations. Okay, so inshallah, we are going to outline introduction and purpose of controller, control components, normally open and normally closed contacts. We are going to see the relay coil exciting current, and we will have one example. Regarding control diagrams, we will take some of the examples. We are going to discuss jogging and what is the benefit of jogging. We will see reversing the direction of the rotation, plugging, and we will have examples included. Okay, one example included. Okay, as a start, we know that control is a very very wide very wide used in the industry, and we need control for starting the motor, accelerating, reversal, deaccelerating the motor, stopping a motor, and if we have another loads, we can control the load by either by switching on or switching off. So control is a very important lesson we need to understand very well, and inshallah we are going to discuss basics of control. Okay, and we will see some of the diagrams, inshallah. Some of those diagrams will be complex, but still you can understand it very well because you know the basics class. Okay, so inshallah we will see together, inshallah. Now, some of the complicated and precise automatic applications of electrical control must have certain factors. So those factors is very important for use with particular machines or systems are described in the following paragraphs. Okay, first of all, which is starting. So if we need to start a motor, okay, we can connect it directly across the source of voltage. Slow and gradual starting may be required, not only to protect the machine, but also to ensure that the line current inrush on starting is not too great. So we know that from the practical sessions, we know that starting is very critical for a motor. So we need to gradually increase the voltage to overcome the problem with the inrush current, with the starting current. Okay, that's why we need controlling starting of the motor. Okay, and it is very important factor. Now, second factor, which is stopping. So motors some impose braking action when the machine must stop quickly. Quick stopping is a vital function of the controller for emergency stops. So if you have a machine, okay, and then we need to stop the machine, we have an emergency stop push button to cut the power from the machine and stop. In case we need the motor to stop directly, we need to connect a brake coil to the shaft of the motor in order to stop the motor directly. Okay, now the third factor is reversing. Reversing is very important in some of the examples in the industry. One of them is for conveyor belt. So if we need to shift one product from one side to another side, we need, as you can see here, this is the conveyor belt. Okay, sorry. So this is the conveyor belt, okay, and this is the product. So in case we need the product going this side or the other side, we need just only to make the motor, here is the motor, to make it forward, okay, or reverse. So to control the product on the conveyor belt, we need to control the motor by going forward or reverse. That's why it is very important. The reversing action of the controller is a continual process in many industry applications. Okay, now for running, the fourth factor, which is running. So maintaining desired operation speed and characteristics is a prime purpose and function of controllers. They protect motors, operators, machines, and material while running. So sometimes we need to control the speed of the motor. Okay. Now, in order to control the speed of the motor for squirrel cage induction motor, we need to have a variable frequency drive in order to change the frequency, and then we will inshallah control the speed of the motor. So running is very important factor, and some of the operations in the industry needs some desired operational speeds. That's why it is a factor in our lesson today. Okay. Now, speed control. Some controllers can maintain very precise speed for industry process. Other controllers can change the speed of the motor either in steps or gradual through a continuous range of speed. So the difference between the 2 points here, running and controlling speed, here we can change the condition of the motor to go for running and control it from to protect motor operators and machines. But here in this side, speed control is to be precise with the speed control. We are focusing on the speed itself, so we can go by steps. Okay, sorry. We can go by steps, or we can grow gradually. So means a step, I mean that we can go 300 revolution per minute. Step number 2, 600. Step number 3, 900 revolution per minute, and so on. But gradually means from 0 to maximum speed. Okay. Now, the sixth factor, which is very important, why do we need controller, is for the safety of the operator. I think this point is very clear. So for in order to save the operator and the machines and everyone around this machine, we need to control everything. Okay. For protection from damage, for the machine itself, we need to control the machine in order to not damaging the machine itself. So, for example, a machine control can reverse, stop, slow, or do whatever is necessary to protect the machine or processed materials. Okay. This is very clear also idea. Maintenance of starting requirement. This is once properly installed and adjusted, motor starters will provide reliable operation of starting time, voltage, current, and torque. This is, guys, very important, and I have seen it in the industry myself. They provide a controller called motor. Okay, let me just motor starters. This device is used to control everything in the motor, from the operation of the starting time, for the voltages, for the current, for the torque. Everything is controlled by motor starters. Okay, and this is very important. I've seen it in Sabic, they use it, and I think in other industries they use it also to govern the selection of motor, and to govern the operation of the motor. Sorry, to govern the operation of the motor. Okay. Now, control component. In control component, we have it depends. Okay, for the size of the control itself. So sometimes we need disconnected switches. Sometimes we need manual circuit breakers, cam switches, push buttons, relays, magnetic contactors, thermal relay and fuses, pilot lights, limit switches, and other special switches, resistor, reactors, transformers, and capacitors. Okay, disconnect switches. Okay, disconnect switches is like the circuit breaker. Okay, manual circuit breakers. Manual, it means that it does not trip, so you can just only have it by eye on or off by yourself. Cam switches in order to have two operations, let's say forward reverse. Okay, push buttons, we know the push buttons. Relay, we know the relay. So let's say like the timer. So this is a relay. Okay, magnetic contactors, and we know the magnetic contactors, and we will see inshallah one by one. Thermal relay and fuses, I think it is clear. The pilot lights, lamp, limit switches, we will see resistors, transformers, capacitors, and so on. Okay. Now, this is the disconnect switch. As you can see from this picture on the right side of these slides, this is a disconnecting switch, isolates the motor from the power source. So this is a three-phase, or let me see. I can see this is a single-phase circuit breaker. Some of the they call it the knife switches here, as you can see here. Let me just you can see it. This is called knife switches. Knife switches means that you need to cut the power or supply the power to the motor. Okay, so these knife switches are used to control manual control. Okay, this is for manual control. Sometimes we have fuses inside. Okay, sometimes we have fuses here on this side in order to protect also the knife switches. Okay. Now, this is the manual circuit breaker. A manual circuit breaker opens and closes a circuit like a toggle switch. It trips, okay, automatically when the current exceeds a predetermined limit. So this is the circuit breaker, and we have the same circuit breaker for the lab, and this is three-phase circuit breaker. As you can see here, the line number 1, line number 2, and line number 3. Okay, and it trips whenever we have a short circuit. Okay, whenever we have short circuit. This is the cam switch. As you can see here, we have in this cam switch we have three positions. Position number 1, position number 2, position number 3, and in each position the connection is changed through the cam switch, and you need to have let's say if you have a motor forward reverse, you can do it manually here by selecting 2 or 3. Okay, so you can do many 3 circuits for the cam switch. Okay, for this cam switch. Now, for the push button, you know the push button. It is well known, and as you can see from this picture, this is normal push button, but so it is activated by finger pressure. This is the control relay, and this is used in the lab. Okay, in lab E026. Jebel Industrial College, and this is a relay coil produces a strong magnetic field which attracts a movable armature, as we can see here. Let me just draw it for you. We know that this contact here, this movable metal, okay, it is attracted whenever we energize this relay. So this is our relay from inside. We have a coil, okay, and we have here a movable contact, movable, sorry, movable armature, okay. So we have a like metal bar here, and we have normally open, normally closed contacts here. This is like normally closed, right? So this is normally closed contact. In order, if we energize this coil according to Faraday's law, we will have a magnetic field. This magnetic field is going to pull the armature to it, and then any normally open contacts will close, and any closed contact will open. Okay. This is the thermal relay, or called overload relay. Overload relay. In case we have an overload problem with the motor, this relay is going to trip to make sure that the motor will not have an access current, and it may burn the motor. It may burn the motor. This is a magnetic contactor. It is the same as the control relay, but here is we have an auxiliary. Okay, see, this is the main contactor, and this is the auxiliary contactor here. So we will have an auxiliary contactor, and this is for high power. Okay, for high power. But the concept is the same. The concept is the same. Okay, now as you can see here, this is the red lamp. Here in the red indicator, pilot light. A pilot light indicates the on-off state of a remote component. Okay, and this is the limit switch. In case this lever is pushed in this side, then we will have a contact, either normally open or normally closed. Then we will have a signal. Okay, so in case anything pushing this lever, then it is going to either switching on or switching off an operation. So this is called limit switch. Limit switch. Okay, so if this limit switch is connected to a door, this is our door. Okay, okay, this is our door. So if we connect this device here, let's say, and you open the door, and this door is going to close, okay, to close the limit switch, then we will have an alarm circuit, and it will indicate that the door is opened. Okay, the door is opened. So this is usually for protection, or even another operation, not only for protection or any another operation. Okay, now in a contactor, we will have a normally open contact, as you can see here. This is normally open contact, and this is normally closed contact. I'm sure that you covered in the lab. Normally open contact, it means that it is open. As you can see here, for normally open contact, okay, we will have an open circuit here. But normally closed contact, we will have a closed circuit. Okay, so this is our contactor in the lab. Okay, and we will have a normally open contacts here, and normally closed contacts here, okay, in the lab. And in case we energize the contactor, then this normally open contact will close, and this normally closed contact will open. Okay, so this is the what I mean by normally open contact and normally closed contact. Inshallah, you will see it in the next slide, inshallah. So when a magnetic contactor is in its de-energized or open position, the magnetic circuit has a very long air gap compared to the contactor is closed. Consequently, in the case of an AC contactor, the inductive reactance of the relay coil is much lower when the contactor is open. So this is will show you the exciting current, So because the coil is excited by a fixed AC voltage, the magnetization current is much higher. So if we energize the contactor, okay, if we energize this coil, as you can see here, if we energize this coil, we will have a current inside, right? But this is an excitation current, which is the very starting current, okay? And we will have a high high current in the starting. It is called magnetization current, and it is much higher in the open than it is in the closed contactor position. Okay, in other words, considerable inrush current is drawn by the relay coil at the moment it is excited. So, in case if you have current through a coil, this will cause us to have a magnetization current, and this is called inrush current, which is very high current, for starting. Okay, uh, we need to consider this exciting current in our inshallah example. As you can see here for this example, a three phase in your left, a three phase NEMA. Don't forget about NEMA. This is just only a name. Size 5, okay, magnetic contactor. Okay, so we are considering a magnetic contactor rated at 270 ampere, 460 volt, possesses a 120 volt 60 hertz relay coil. So it is inside having 120 volt and 60 hertz coil. Okay, now the coil absorbs an apparent power of 2970 volt ampere and 212 volt ampere respectively in the open and closed contactor positions. Okay, so calculate the following: the inrush exciting current. As you can see, the inrush current is the relay coil. So coil, we can take it from the apparent power, right? So the current from the apparent power. So I is equal to S divided by E. S is only the the inrush current, which is, it means that we need the current in the closed position, right? Closed contactor position. So we need to take the S, the apparent power, divided by the voltage of the coil itself, 120 volt of the coil itself. So 2970 divided by 120, which is equal to 24.75 ampere. Now, the normal relay coil current when the contactor is sealed, closed. So the difference between those 2 points is that the first one is the inrush current, so the starting current of the coil. This is our coil again. Okay, so once you energize this coil, we will have inrush current. The inrush current is 24.75. Now, after that, everything is settled down and everything is going smooth. The normal current now, it is 212 divided by 120, which is 1.77. Can you see the difference between those currents? It is very huge difference. Okay, so we need to consider the inrush current in designing a contactor. Okay, in designing a contactor. So the steady state, the B is called the normal sealed exciting current. The control power needed to actuate the relay coil compared to the power handled by the contactor. Okay, so the steady state parent control power needed to actuate the relay coil is 212 volt ampere. So this is just only to operate to operate the relay itself. Okay, to operate the relay. We don't need the power for the inrush current. So the apparent power that the contactor can handle is equal to E, which is the voltage, multiply the current, multiply root 3, because this is a 3-phase, right? So equal to 460 volt for the contactor, multiplied by 270 ampere, multiplied by root 3, which is 215,000 and 120 volt ampere. Okay, so thus the small control power 212 volt ampere can control a load whose power is 215,120 divided by 212, which is equal 1015 times greater. Okay, so this contactor is okay, so we can control a load which is having a power which is 215,120 volt ampere. Okay, so if you have any questions, you can just contact me in inshallah in the next coming discussion lecture. Okay, and inshallah I will explain everything in details. Okay, so this is very clear. For this for this example, we will have three important things, which is for the first one is the inrush current for the relay, the second one is the normal current for the relay, and the how much the load this relay can operate, how much the load this relay can operate. Okay, now control diagram, control system, we can represent the control diagrams by 4 diagrams here. As you can see, we have block diagrams, one line diagram, and it is called single line diagram, wiring diagram, and schematic diagram. We will see one by one. Okay, you can read the right side by yourself. This is called block diagram. Block diagrams means that we have boxes. Okay, we have boxes. As you can see here, for this block diagram, we have a 3-phase. Okay, 600 volt. So the level of the voltage is 600 volt. Now we will have fused disconnected switches, circuit breakers. We will have a magnetic contactor that control everything. We will have pilot lamp to see the motor is it running. We have also push buttons in order to start or stop. We will have thermal overload relay, and we will have the motor. It is represented as boxes. Okay, so the system is represented as blocks. Okay, so it is called block diagram. Now let us see the second diagram, which is called one line diagram or single phase or single line diagram. So it is mentioned here, it is 600 volt 3-phase system. 3-phase means I need 3 lines, right? And they are representing one line. So it is called one line diagram. No need to represent the other 3 lines. So just only one line diagram. You will understand everything. You will understand the control of this circuit. So let us see together. So we will have a supply, which is 600 volt 3-phase. We will have a disconnect switch. We will have a fuse, and then we will have a push button, as you can see from downside here. We will have a push button, and we'll have another push button for stop, and we will have violet light, and this is the symbol of the violet light, and we will have a relay in order to close this contact, normally open contact, in order to operate this motor. And in case we have an overload, this is the thermal overload relay. Okay, and this is called single line diagram. Now let us see the wiring diagram. Wiring diagram means it is the connection diagram. So we will have 3-phase, as you can see here. Okay, this is our 3-phase connected to a disconnected switch, and going out from the disconnected switch to the starter. Okay, and going from the starter, we will have push button start and stop, and we will have a motor, and we will have a lamp to indicate that the motor is running. This is the starter that I'm talking about. Okay, this is the starter to control the motor, everything for the motor. So as we can see, we have three lines going from from the supply to the motor. Okay, through the magnetic contactor, through the push buttons, everything. So this is called wiring diagram. Wiring diagram. Now this is the actual diagram in the labs. Okay, and this is called schematic diagram, and it is representing every part of the control circuit, and with the symbols itself. Okay, so we will have three phase 600 volt, 1 to 3. It is connected to a switch, disconnected switch, and then to the fuse, and then it is going to the normally open contact of the normally open contact of contactor A, and we will have a thermal contact from the overload relay, and we will have this motor. This is our motor, three-phase motor. Okay. We will have also a stop push button, a start push button. We have contactor here. We have the lamp here, and we have this is from the overload relay, and this is from the contactor to have holding contact, inshallah. Okay, and this is called schematic diagram. Okay, jogging is very important in industry. Jogging means that in case you need to start the motor, to rotate the motor a little bit. Okay, so let's say that this is your motor connected to a conveyor belt. Okay, and this is your material. Okay, you need to take this material to this position. Okay, this is the point that you need it here. Okay, we will call it here. So in order to move this material to here, you need to switch on and switch off the motor, right, to go this side. So you're going forward. So we need to switch on, switch off, switch on until you reach this point, and then we can take it. And this is very important for the industry, and it is not required for long operations. Okay, this is just only for in case if you have problem, then you can use the jogging method. And as you can see here, we have stop push button, we have start push button, and this is the jogging push button. So in case, okay, so in case you have you need to shift the material a little bit. Okay, you need to press jogging, then you are going to close this contact, and you will have a power like this going to the contactor, and you are going to move the motor, right? And this is just only to give pulses, right? It is going to give pulses. So as you can see here, J is added to the usual start stop push button as shown. This arrangement permits conventional start stop control as well as jogging or inching. Inching means give more inches. Inches is it's like centimeter, but it is the size is inches. So from its name, that you need to move the motor a little bit, move the material a little bit by inches. That's why you need we call it jogging or inching. Okay, so the following description shows that how the control circuit operates. This is the reversing of the motor. We know that in case we need the motor to going forward or reverse, we need to only interchange between between any two lines. Okay, so if we have 1 2 3, then we are going to forward. If we have 1 3 2, we will have a reverse. Okay, so this is just only control, and this is the connection terminal is ABC to the motor, as you can see here. And but when contactor P is closed, the same lines are connected to the motor terminal CPA, as you can see here. Let us follow this one. So this is C connected to A, and B is connected to B, and A is connected to C. So we are reversing two or interchanging two terminals. Then we are going to reverse. This is the cam switch, okay? And we have two position, 1 and 2. 1 for forward, 2 for reverse, okay? This is very simple circuit. Please try to read this operation. This is for start and stop, but this time we have an interlock, electrical interlock and mechanical interlock. A mechanical interlock from the through the push button. Sorry. Okay, please try to read the operation here. Okay, this is the operation. We have already seen that the induction motor can be brought to a rapid stop by reversing two of the lines. Okay, however, to prevent the motor from running in reverse, a zero speed switch must open the line as soon as the machine has come to reset. So as you can see, for this circuit we have something new, which is zero speed switch. Okay, this is for plugging. In order to stop the motor, we need to reverse the direction, right? So but this is very critical because we don't have much time. That's why we have zero speed. When we reverse the motor of course will go to through this zero speed, and then it will increase the speed in the other direction, right? So this is very important. So when we have a zero speed, then this switch is going to be open to make sure that it is not going to the reverse. Okay, this is for the plugging. Okay, this is very important for the plugging. Please read the procedure, and this is all about our lecture inshallah today.